Welcome. Thank you for joining me for your first flipped classroom lesson. So I know we already talked about this in class, but I just want to reiterate some of the good habits to have while you're watching one of my videos. First of all, make sure you have your note packet out because obviously this video is going to fall exactly along with your note packet. Have something to write with, pencil preferably, if not pen, so you can copy everything down. Then I also always recommend have a calculator with you because again, just watching me do this isn't as meaningful as if you are interacting with my notes. So make sure you have a calculator so as I'm doing something, make sure you can do it on your calculator too so you're aware of the skills that I'm talking about. Now, every time that you come across one of these videos, first thing you're going to notice is I'm going to label the lesson for you and what the title is. So here, properties of real numbers is what we're going to cover first. Right away following that, I'm going to label out the learning targets that this lesson is going to cover. So today we're going to talk about how to graph and order real numbers and to identify properties of real numbers. So before we start talking about properties and putting them in order and graphing them, the first thing that I want to comment on is just creating subsets, creating a language so when I use certain vocabulary, you'll know what types of numbers that I'm talking about, okay? This is a skill not only I assess in class, but it very commonly shows up on things like the ACT, MCAs, stuff like that. So when we're talking about real numbers, we're going to start with this innermost part of the real numbers, okay? So we're talking about numbers 1, 2, 3. I call these the counting numbers, okay, where you're literally just able to count physical things that you see. Those types of numbers are called the natural numbers, okay? And again, they're just counting numbers, 1, 2, 3, 4, so on and so forth. Well, eventually, it came into agreement that there is such an idea as having nothing. So then our number system had to expand, okay? Not only to include 1, 2, 3, 4, so on and so forth, but to also include this idea of nothing or the idea of zero, okay? Once a zero was added into the number set, we gave it a new name. We call those the whole numbers. And again, just to reiterate, all a whole number means is 0 and then all of those counting numbers, 1, 2, 3, 4, so on and so forth. Well, even after that, our number system had to expand, okay? Because then we started realizing, well, there's more than even just that. There's also the negative numbers, the negative versions of all of those. Once we start incorporating negatives in, that's when we're talking about the integers, okay? Most kids really like integers. You're good at working with them. They're pretty easy to do mentally. So that's usually where you're most comfortable, working with integer values, okay? Well, of course, we realized even that is not big enough, okay? There are other numbers out there. What if I have part of a something, okay? So that is when we started diving into fractions and stuff like that. We call these the rational numbers, okay? Now, rational numbers are where some good conversation is, okay? This is usually when being assessed. This is where the true stuff comes in, ACT, stuff like that, okay? So rational numbers, by definition, are all the numbers you can write as a quotient of two integers. So essentially, saying a fraction. So for example, -1/2, okay, is a good example. Now, that's not the only thing that's included though, okay? It also includes terminating decimals, okay? So numbers like 6.1, 0.222. So anything that has a decimal that you can see the end to. Now, why does that still work based on our definition? Well, because something like 0.5, well, 0.5 can be written as 1/2, okay? So that's why it still works out. So terminating decimals will also be included in the rational numbers. However, that's not the only kind of decimal that is. Also decimals that repeat at the end. Now, they already gave a good example of this one right here, okay? Something like 0.3, and that little bar means repeating. So that'd be 0.3333333 forever, okay? And again, we commonly know that as 1/3. I think that's one that all of you guys already know. But the idea is because it can be written as 1/3, it still counts as a rational number. Okay? So those are kind of the subcategories that all fit into that rational number system. Okay? Now, lo and behold, shocker, it goes even bigger than that, okay? Things that are called the irrational numbers that cannot be written as a fraction of two integers, okay? Now, for the beginning of our course, there's two very common examples, okay? The number pi, which you guys were exposed to back in geometry, that is irrational. And I call irrational numbers basically number vomit. If you type that into the calculator, it's going to spit out this never-ending decimal that also never repeats itself. Okay? That's what makes an irrational number. Also, another very common example, many square roots are irrational. Okay? Now, I do urge you to be thoughtful on that because if I gave you something like square root of 16, well, that's not irrational because that's just the number 4. That would still go into my rational category. So don't see square root and just automatically assume it's irrational. Do make sure that it's a nasty square root. By nasty, I mean you type it in the calculator, never ending, never repeating. Okay? Now, and again, just to re-emphasize, it is something that cannot be written as a quotient of two integers. Okay? So that kind of sums up all the types of numbers we're going to be dealing with for the most part in Algebra 2. Okay, so let's take a look at, if I give you a scenario, can we put it into a number system? Okay, so for example, if I'm talking about the number of people participating in a race, what types of numbers are described by this? Well, there could be one person in the race, two people in the race, 3, 4, or so on and so forth. Okay, so here I'm going to call this the natural numbers. Okay, I could use the natural numbers to describe the possibilities for describing the number of participants in a race. Okay, now what about the time it takes to drive to school? Okay, well, I can't have negative time, right? That doesn't make sense. So I could have something like 15 minutes. Maybe some people have a 20-minute drive. But another possibility is it could take me maybe 16 and a half minutes, right? So here, I do need fractions, okay, or decimals, all right, to describe all the possible numbers that could be included. So where do I have to go in my number set here to include fractions? Well, fractions don't come in until down here. They don't come in until the rational numbers. Okay, so I am going to call this a rational amount because I need decimals and fractions for the possibility that it's not going to be just a whole number amount of time. What about the amount of money in your bank account? Well, you could have positive money. You could have decimal money. You could even have negative money. You could owe the bank money. Now that's not a fun scenario, but it's very possible. So what I'm looking for here is I need negatives and I need fractions. Well, decimals. Once again, that's going to land me in that same place right here, okay? As soon as I know that I need decimals or fractions, that automatically tells me that I'm going to be looking at rational numbers. So this, once again, is going to be the rational number system in order to describe those possible values, okay? So now that we've established that common language, now let's talk about how do we deal with these numbers, okay? Because a big part of math is making comparisons. I'm going to get answers and I'm going to be expected to compare these answers to each other. Now, when comparing, you're going to want a common form to compare those numbers in, okay? Now, the easiest way to do that is decimal form. I think all of us are very comfortable with decimals, and so that's the easiest way to compare values. So if I gave you something like square root of 3 and asked for some comparisons compared to other numbers, I would type that in the calculator to get a decimal form, and I would say that is approximately 1.73, okay? So I could give you a list of numbers and then ask you to put them on a number line for me. Now again, making comparisons, something like that, putting them on a number line, decimals are going to be the easiest way to do this. So -5/2. I'm just going to type in the calculator, and that's going to be -2.5. All right, so -2.5 would put me right here. Square root of 2. Type that into the calculator, and the calculator is going to give me 1.41 blah, blah, blah. I don't need more than that, okay? So 1.41 is going to be approximately right here. So there's my square root of 2. 2.6 repeating, all that means is 2.666 going on forever, okay? That's basically already in its decimal form. So that is going to be about right there. Okay, again, the kids, whenever you're being asked to plot something on a number line or a graph or a comparison, make sure you put it in its decimal form. All right, and this next example is going to continue to reiterate that for us, okay? So square root of 3, well, we already saw up top, is approximately 1.73. So that's going to put me about right there. 1.4 repeating is, again, just repeat that 4. So 1.44, that's going to be right here. And I'm going to write that down below because I'm getting squished for space right there. 1/3 is 0.3 repeating. That's going to be about right there. So another skill set to have beyond just graphing is also making comparisons, okay, using those signs. Now, again, just in case you've forgotten, the way that I describe it, even though it's really cheesy, is think of it like Pac-Man. Pac-Man wants to eat the bigger number, okay? So it's going to have its mouth opening towards the larger number, okay? So even in those comparisons, again, we're going to want decimal forms. So I'm going to convert that square root of 17 to be about 4.12. Now, in that form, it's going to be much easier to see that it should be opening towards that because that is going to be the larger number. And what about the next one? Well, negative square root of 26. That's going to be negative point, oops, sorry, not negative point, negative 5.10 approximately. Again, just typed it in my calculator. Now this one, be very careful with. Both of them are negative numbers, okay? When both of them are negative numbers, it is the one that is closer to 0 that is actually bigger. So it's a little bit deceptive, okay? So just be very careful when both are negative, okay? Because again, it's very easy to mix that up, but all you're looking for is the one that's closer to 0 in that instance, because that one is going to be technically larger. So we've discussed the sets of numbers. We've talked about how to make proper comparisons between numbers. Now let's wrap up by talking about the properties of numbers. This is kind of the big idea of today's lesson, is the properties that they have. So let's run through these numerous properties, and then I'll do a couple of examples, and then I will let you go. First one we're going to be working with is the associative property. Associative property deals with grouping. So again, I even give you the hint. Think about who you associate with. Use that to remind you that association, it deals with grouping. So notice the only difference here is here the A is by itself, the B and C are grouped. Here, the group changed, but it doesn't change the value. The value remains consistent. That's what this property says, is for addition and multiplication, it doesn't matter how you do your grouping, whether you add A with the B and the C, or you add the A and the B with the C, it doesn't matter, you're going to get the same value. So that's what the associative property says. So what does that mean? Well, let's take a look at this. That gives you 6, right? 1 plus 5. Well, all it's saying is that's the same as 3 plus 3, okay? That's what the associative property of addition and multiplication says, okay? The way you group doesn't matter. You're going to get the same thing in the end. 3 equals 3, okay? So that's property number 1 that I need you to know. And again, remember, associate is like association. Who do you hang out with? Who do you group yourself around? Well, commutative deals with order. So same thing for multiplication and addition. If you do A plus B, that's exactly the same as B plus A. Or if you do A times B, that's the same as B times A. Example here, if I have -3 times 4, commutative, the order, says that that should be the same as 4 times -3. Okay? So, first two properties, as simple as that, okay? Grouping, you can change it up, doesn't matter. Or second one, the order, you can switch it up, doesn't matter. Distributive. So distributive property, this is something you've done for a long time. This one, I've never had a student really struggle much identifying this property. Essentially, all it says is if you have something outside that is multiplying a parenthesis, you just multiply it in, okay? So basically what it's saying is this. So this is going to be the same as that. You distribute the 2 to both of them. Now let's see, does that hold true? Well, this is 14. Here, 2 times 7 is also 14. So it does, it works, okay? And again, when it comes to identifying these properties, I've never had a kid struggle identifying that one. Is one you've worked with for quite a few years already. All right, now, the two that I think the idea you have already encountered, but now we're going to give it a name here in Algebra 2, okay? So the first one is called the identity. The identity is the thing that when you do it to that operation, it doesn't change the value, okay? So for example, for addition, the identity is 0, okay? Because if you take anything like 1 plus 0, it doesn't change. The whole idea with the identity is no change occurs, okay? For multiplication, the identity is 1. If I multiply something by 1, it doesn't change. So there's two different identities. Addition is 0, and multiplication is 1, okay? Now, there is another property, okay? The inverse. And what the inverse does is it's what takes you back to the identity, okay? So that's what the inverse operation does, is you give a number and then it does something to bring you back to the identity. So for addition, to bring you back to the identity would just mean using the opposite or the negative of a number, okay? So for example, to bring 2 back to the identity, I would use -2, okay? For multiplication, it means the reciprocal, okay? So let's say I'm starting with 4. Well, I have to multiply it by 1 over 4 to get back to the identity, okay? So here it's important, you need to understand this idea of identity before you can understand the idea of inverse, okay? Those two go directly hand in hand with each other. All right, so there's our big list of things. Now, let's talk about identifying them, okay? That's going to be the biggest key here, is identification. So, determine which property of real numbers um, of each, or that each of the following illustrates. Here, what I'm noticing is I'm taking a number and I'm multiplying it by something to get 1. But that sounds really familiar. And in fact, hopefully you can see I'm multiplying by the reciprocal. I'm multiplying by the flip of 2/3 to bring it back to 1, which is the identity. So remember, if I'm doing something to bring it back to the identity, that's going to be the inverse. All right, now this next one. I notice there's grouping, okay? But the thing that I notice is it's not the grouping that's necessarily changing. Notice within this group, what's happening? Well, the order is changing within that group, okay? So if I'm changing the order is actually the commutative property, okay? So, commutative property. And this last one, I notice I'm taking that 3, multiplying it throughout that parenthesis. So this, again, is the one that I think most kids identify pretty easily. That is the distributive property. All right, just a little more practice here, just to make sure that you feel comfortable with these before I let you go. All right, so what property? Here I notice the order is changing. So order means commutative property. Now, to be precise, you can put a multiplication. That is not my expectation during class, okay? I'll just be happy if you put commutative. Here, I see the grouping is changing. When the grouping itself is changing, that is the associative property. Here, I see the order changing, okay? Whenever the order is changing, again, that is going to be commutative, and you're flipping it via addition. Again, if you just put commutative, I would be perfectly happy. Here, I'm performing an operation that doesn't change the value of that 5. When you perform an operation that doesn't change anything, that is the identity. What about when I perform an operation that brings you back to the identity? So here I'm adding something to result in 0. Remember, to bring you back to an identity is called inverse. And then here I'm adding something in that results in no change. That is going to be identity as well. All right, so hopefully after all of these examples, it kind of clears things up for you and you've got this down. Now, the way this works is after you watch this video, after you have all of this written out, you'll come back the next day, I'll check over your notes, and then I'll have worksheet activities and stuff like that for you to do in class. Now, you may notice this summary down here at the bottom. Tonight, don't worry about the summary, okay? I'm gonna model one in class with you so you can kind of see an appropriate expectation for what to do with the summary. Then from then on, after you're done with the video, I will have you be writing summaries for me to kind of recap the big ideas that you got out of it to help you focus your studying and make sure that you're connecting the dots with everything I'm trying to explain. All right, so thank you so much for joining me through this. I really appreciate it. So just come back with this packet completed, ready for tomorrow, and then we can kind of talk through the next phase of the flipped classroom.